So today we'll be talking about how you can manage your microservice with a framework called Istio. I'm pretty sure I'll not be talking about, hey, why microservices are awesome, why you should move there, etc., etc. There are a lot of articles on the internet that speak about, various microservices pattern, and you can basically go read up if it's, of value to you, right? Not every systems can be designed in a microservice fashion. But yeah, so this talk predominantly will focus on how you can efficiently manage your microservices, right? So who am I? Thanks Ashima for the intro. So my name is Muthuramakrishnan. It's quite a big name, so Ashima took the chance of pronouncing my second name, so that's cool. So I've been working with Google for about 2 years now, as a technical solutions consultant. So I've been an open source developer in my past, before Google, and I've released libraries for Android, Node.js, etc. Before I started this role. And I had my own startup for a while. It was a small stint, right? And I'm also, apart from, if I'm not immersed in software, you'll find me mostly DJing or producing some music somewhere, right? So that's about me. And now let's get on to the topic. So how many of you have seen a slide like this before? Probably in a microservice talk somewhere. Yeah, a couple of hands showing up. So again, right, I want to reiterate that we won't be talking about how you can, go the microservice way, right? Because there were quite a movement that happened before, like a couple of years back. Hey, microservice was a buzzword, and everyone started looking upon it, and people started doing it. But today we'll focus on a framework called Istio, right? So we'll talk more about it, right? But before I talk about Istio, I want to kind of give you a quick intro on why Istio, right? Why people, why the developers at Google, IBM, Lyft, etc. Came out with Istio, right? So we'll go through that, right? So if you think about any microservice, right, or any application itself, it's like a combination of multiple services, right? You can think about that. Like for example, let's say you're building an e-commerce application, you might have a cart service or a notification service, or even your user service, etc. So let's assume that for this talk, hey, each and every microservice is designed to do something specific for your application, like for example notifications or placing an order, etc. Right? So and as developers started doing microservices, right, they came across multiple challenges. So they were predominantly kind of fell under the infrastructure level, right? So if you think about the challenges that the developers faced while they moved on to a microservice-based architecture, you can see challenges like deployment. Like how do I take all these? So now we have instead of one application, we have some 100 services that we have to deploy and manage them across. And how do we make sure they talk to each other properly? And how do you make sure each of these communication is secure, right? So these were some of the challenges that predominantly around infrastructure that microservice developers faced while they decided to move on to that type of architecture, right? Luckily we had a lot of container technologies that showed up. The evolution of container technologies really helped us in solving those problems, like predominantly around, hey, how do I containerize an application and just let it run, right? And how do I manage these containers, etc., etc. And Kubernetes, which is an open source contribution from Google, essentially started out based on our internal systems that is called Bog, and where we at Google used to manage billions of containers efficiently, right? So that was Kubernetes, and so far we have been using Kubernetes, Cloud Foundry, and other similar container technologies to actually at the boon of developers to make sure it helps you connect all these containers efficiently, right? So, but there are problems beyond that. So right now we have container technologies which have evolved, and once we have deployed all these microservices, they look like this, right? pretty much everything talks to each other, and you have multiple other challenges that come forward when you move to this architecture. So what does this look like? A mesh, right? Or a mess probably, right? But either way, it looks like a mesh. So essentially, that was the starting point, right? So if you think about all these services talking to each other, right? It kind of formed a mesh pattern, right? And the term service mesh was coined, right? And there were people who were working on service mesh before, but it was not a widespread effect. And why service mesh as a concept came into the picture was basically to address some challenges that were that came in because people decided to move to a microservice-based architecture. So what are these problems? So these problems are generally you can define them as problems beyond deployment, right? So what are these problems beyond deployment? So I saw some microservice developers here. I would love to hear some of your thoughts, like what challenges did you face while moving to a microservice-based architecture? Can someone just give me like a couple of challenges that you faced? Yeah, please. Storage. Okay.
So persistent storage, especially in the world of databases.
Sure.
When we are talking of big data.
Yeah.
It really thinks of us to be in a scary mode. What happens with container world?
Right.
When you take some of those databases
Sure.
or HDFS,
Yes.
and that becomes little scary to think, well, what happens when your container goes off? Does it
Right.
let it die?
Yes.
Or what happens to, how do we solve that problem?
Right. So yeah, that's a great problem to have. And similarly at the parallel level, right? When you think about problems beyond deployment, storage is one factor, and essentially, we had a set of people, DevOps people, in every company who typically manages, all these systems, to make sure, hey, is this system running or not? If this system is connected to a database, what if this container goes down, right? So what do I do next? How do I actually find what system went down, right? So these are the questions that as a DevOps person or as an operator, I should address to make sure my services are running efficiently, right? So I mean, some of these problems can be grouped under the problems that I've just put forward here, but this is not an exhaustive list. There is more to this, right? Including, I'm sorry I didn't get your name, including what Ashish was also talking about, right? But the scope of what we'll be discussing is pretty much going to be at the mesh level, right? So this is on top of your or just between your containers and your infrastructure, right? So where you have a mesh, and how do you use that mesh to solve some of these problems around load balancing, right? Or even observability, etc. So what do I mean by load balancing here? So you have L4, L7 load balancing, right? So L4 load balancing is basically, hey, you have a bunch of TCP packets coming in, based on the number of packets that comes in, you just route it wherever you want, and based on the resource utilization, etc., etc. But there was this, there is also something called L7 load balancing. Pretty much at the application layer, you want to understand who is hitting your service, right? For example, let's say an iOS user is hitting your service, and you want to cater some different message to them, right, rather than an Android user, right? So how do you do all those things? Like how do you do content-based traffic steering? And also how do you do things like canary versus prod? How do you effortlessly do that? How do you not hard code this in your services, right? And also a very simple example that I could think of is, hey, every application developer today will have some sort of a framework that they use to do the authentication for the calls that are coming in, right? To verify the calls, requests that come into the system. So essentially, if you think about in a microservices world, each and every service developer has to implement that to make sure the call goes through properly, or someone has to actually take it out or have it separately and manage that. But if you take a step back and think about how you can take all these non-functional requirements, as I'd like to call it, and put it at the mesh layer, right? So that's what Istio will help you with. So, and obviously, to tackle these problems, we have a lot of open source tools that are available, right? So we have Eureka, we have Hystrix for circuit breaking, etc. So any of you use any of these tools here today? Which of these tools would Prometheus? Yeah, Prometheus is a very common example on how you can do like time series analysis, or how you can understand, hey, what is the call that came in, like end to end, tie it up, what was the request, etc. Right? And obviously, I think most of you would also be aware of Grafana, where we use it's a plugin to put it on top of Prometheus. I can visualize all these calls that came in. So today, if you think about how you're doing this, all these pretty much involve some sort of client code. Like you'll use some sort of libraries in your application. You'll have you have a system where you push everything that takes care of doing all these. But what if a system that is there to actually that abstracts all these for you, right? So let's say today you're using Prometheus, and tomorrow you want to go to something else, right? How do you do that easily? But today, if you have to like go change it, you'll have to go and modify your source code. You have to like change your libraries, etc. So how do you make sure you can easily change between the services that you're using, the tools you're using, etc. So today I just spoke about this. Every microservice would look like this. Like you have a service, and you have all these components inside your service, right? And they pretty much talk to the like, for example, Eureka for service discovery, etc. And this is a problem. Can someone tell me what type of problems might arise when you do things like this?
If you are compatible with multiple APIs, different types of APIs that these tools support.
Okay. Yes, one thing. And anything else? Version management. Yeah. Like what if so if you look at with more services, let's say service A is developed by team A and service B is developed by team B. What if one person uses a different version of Hystrix and than service B developer or service A developer, right? What if there is a mismatch in there, and how do you tackle all these things, right? So essentially, this would probably go back to a microservice nightmare, where people might think that, hey, I'll rather go back and do full stack, just single stack. I don't mind. I'll just go and do with monolith applications. So well, you can actually, the solution that I just spoke about. Either someone can say, hey, I'll just use a single stack. I don't care, and I'll just do this. Or someone might be like, hey, I have Spring Boot, right? How many of you use Spring Boot here? Wow. So I can use Spring Boot, right? Yes, you can. But when you actually, think about the problems that come with it, like for example, let's say Spring Boot is great for small teams, right? But as your team grows, right, as you get more people involved in your projects, where there are developers, who prefer a different language than Java or anything else, right? So they are polyglots. They want to like keep experimenting with new languages, new systems, etc. So how do you cater to them? And also probably someone might have legacy systems, right? That was coded a long time back, and they are pretty much a monolith. You cannot, unless you rewrite them, you cannot really change them. So how do you connect to them, right? So these are some challenges that that any developer would face as they move towards a microservice-based architecture. So to summarize all these things together, as a developer, what do I want? Like, I'm a service developer. I just need to make sure I'm able to talk to service B if I need anything, and it should be a simple HTTP call, nothing else. And every other non-functional requirements, I spoke to you about non-functional requirements, right? So every other non-functional requirement should be handled by someone else. It's not my duty, right? So here, this translates to the ultimate goal of having developers just focus on business logic and not anything else, right? So who would agree to that point here? Okay. So essentially, that's where Istio comes into the picture, right? So to take all these challenges that we spoke about and abstracting out a layer where you can add plugins like Prometheus or Zipkin or anything else, and helping developers efficiently focus on writing business logic, right? So what is Istio? Istio is a complete framework to secure, manage, and connect microservices, right? It's an open platform, it's open source. It's with key contributions from Google, IBM, and Lyft, and others as well. It is multi-platform, but it is built, Kubernetes first. So it works natively with Kubernetes, right? So you don't really have to do any extra configuration. So that's what Istio is, right? So in the next few minutes or so, I'll walk you through the architecture of Istio, right? So we'll see what are the components that are involved in Istio, right? And what do these components do? And we'll also see how a life of a request inside a service mesh. Okay, so Istio addresses, three, or Istio provides three values, on the top. Essentially, number one, to control your services effectively. How do you have control features put in picture and make sure these are not built as part of your services, right? And observability, how easily can an operator go and look at logs, go and look at syslog traces, etc., right? And how easily you can make sure every call to your microservice is secure no matter what. So these are the three things that Istio offers. And right now your service would look like this after, once you have Istio in place. So all these things are gone, right? So in spite of this, what we are going to do is we're going to follow a sidecar pattern. So can someone define what a sidecar is here? Sidecar proxy?
Application not written in Java, they can connect with directly sidecar. The sidecar act as a discovery, is connecting with the microservice.
Okay, so very close. So essentially what we do is the service that you have, the microservice that you have today, when you deploy it on Kubernetes, it's a container that is running as part of a pod or something else, right? So what we do is, as part of that pod, we just introduce another container that's just a proxy. So instead of talking to the service directly, we'll just talk to the proxy, right? So I'll simplify this a bit more for you. If you think of any call that comes in today to your service, it directly hits the service, right? Instead of that, it'll hit the proxy first, and the proxy will decide the things that it has to do before forwarding the request to your service. So that's what a sidecar architecture looks like. So, and a quick meme here: everyone gets a sidecar proxy at in Istio. Any service that you deploy will get a sidecar proxy, and it's all managed for you, right? So we'll talk about how these proxies are managed, right? So and there are obviously more problems that arise with this type of architecture because you're introducing one more component that needs managing, right? So here there is another layer of abstraction that needs to be managed very effectively so that you can just focus on service, building service, right?
So this proxy will be part of pod only?
Yes, it's part of the pod.
How different it is from API gateway?
Yeah, we'll talk about that, right? So, I'll address some of these questions as we move forward, right? So if you think about what this proxy is, first of all, it's Envoy proxy. Have someone come across Envoy proxy here before? Anyone? No? Okay. So Envoy is a C++ based L4 L7 proxy, right? It was developed at Lyft, right? It's highly battle tested. So they have tried running about 100 services across 10,000 VMs with a peak QPS of 2 million transactions per second, right? And it supports HTTP2 and gRPC. Anyone uses gRPC here? Okay, very few. Cool. HTTP2? Okay, very few. Sorry? Yeah, I mean, I'm just, some people might not use gRPC, but just, use HTTP2, but yeah. So some of the, contributions that Istio developers made to Envoy are, traffic routing, splitting, fault tolerance, etc. And, why Envoy was chosen, because it is really extensible, right? It was Envoy was written with extensibility in mind, and it really has been helpful to connect with the type of architecture that Istio had proposed earlier. So that is the sidecar proxy, and to manage all these proxies, we introduce a component called a pilot, right? So if you think about, so there is something called a data plane, right? So the proxy here falls under the data plane, right? Or the whole box here falls under the data plane. And you have the control plane where you have Istio components controlling the components inside data plane, right? So I'll simplify this even further for you, right? So an operator would just give out the routing rules, say, hey, service A has to go here, www dot whatever has to go here, etc., etc. And your service discovery and rules will be translated to an Envoy config and be pushed onto the Envoy proxy, right, by the pilot. So that is pilot here. And you have mixer, right? So mixer is the part where we apply adapters, policies, and everything else. So to your question on how is this different from API gateway? So API gateway is there are multiple ways you can use API gateways. You can either put it in front of your whole system, act as a reverse proxy, or you can follow a pattern like this, right? So you can have small sidecars, right? So these are small, simple gateways that sit along with your services, right? And all your policies, like let's say quota, etc., will be taken care at the mixer level, right? So mixer is the policy decision engine. All your rules, everything will be defined at the mixer layer, right? So that's what mixer does. And Citadel. So Citadel is the component that ensures secure communication between service A and service B, or B and C, etc. Right? So we saw 3 components, right? Or 4 components to be precise. We saw the Envoy proxy, which is a sidecar proxy. We saw pilot, we saw mixer, and we saw Citadel, right? So how does this translate into the architecture? So this is how the Istio architecture looks like. So this is the control plane, right? And this is your data plane, right? So the operators will deal at this layer. They will be defining the rules for service communication, policy decision, etc., telemetry, and everything else at this layer. And the developers, service developers, will be predominantly focused on this layer. And then just to clarify here, service developers will just focus on writing the service. They don't really have to worry about the sidecar proxy because it's transparent. It's just pushed when you deploy the service, right? So those are the components. So now we'll just quickly see the life of a request in Istio, right? So first of all, when you install Istio and configure it, all these components come up, right? Pilot, mixer, Citadel comes up. And when you bring in a service, when you deploy a service, a proxy is automatically injected in there, and pilot will push all the routing configurations to the proxy, so it knows where to call, what to call for like service B in case if it needs to communicate with service B, etc. And Citadel pushes all the certificates required to do mutual TLS, right? So this is the first step when you actually go and push a service to service on the cluster. And let's say a service A is trying to call service B for some reason. So in this case, the client side Envoy will intercept the call, right? And it will know where to push the call to, right? It will have, so because since pilot has already pushed the configuration, proxy the client side proxy will know where to push the call to. And when the call is pushed forward to the proxy, it will see, hey, it will go at the mixer level and understand, hey, is this service allowed to call me, right? And is the quota available for the service to call me, etc., etc. So all these things are taken care at this level, and this is where the policy checks happen. And once everything looks good, the call will go through, and the proxy will automatically forward the call to the service B, and the response is given back to the proxy, and the proxy again gives back the response to this proxy, which again goes back and pushes the telemetry info, etc. And this proxy will give back the call to the service A, right? So this is the summarized life of request inside the mesh, right? So essentially, this will also push some telemetry information after this to your all your plugins can visualize, right? So your Prometheus or Zipkin, etc., etc. So that is all I had for this particular session. It was a very quick introduction on Istio. So as part of Google developers, we have communities, right? So that we focus on all these open source technologies from Google, right? It's called Google Developer Groups, right? Anyone part of Google Developer Group here in Bangalore or anywhere else? Awesome, some of you. I would seriously recommend if you to go and check out the events that we have meetups all around, and we pretty much discuss the open source technologies and other technologies that Google has to offer for you to build better services and applications, right? So that's all I had. Thank you. I'll be around. If you have any questions, I'll take them offline probably. Thank you.